Welcome to this 10-part series on the basics of nautical navigation. In today's video, we'll be diving into Lesson 3 on distance, depth and height, one of the essential steps to mastering navigation. Be sure to check out the other videos in the series for a complete understanding of navigating the seas.
We will now cover distance, depth and height. These are fundamental concepts that every mariner needs to understand to navigate safely and effectively. Let's get started. Distance. At sea, distance is measured in nautical miles or meters. 1 nautical mile is equivalent to 1,852 meters. This measurement is based on the Earth's geography. Specifically, it represents the length of 1 minute of latitude. This is why the latitude scale on nautical charts can also be used to measure distances. By comparison, a statute mile, used on land, equals 1,609.3 meters. This unit is not used in marine navigation, so always think in terms of nautical miles when at sea. Speed. Mariners measure speed using knots, where 1 knot equals 1 nautical mile per hour. When discussing speed, remember to avoid the term knots per hour, as it is redundant and incorrect. A vessel's speed is simply measured in knots. Historically, sailors measured speed using a log line, where a piece of wood was thrown into the water, and the time it took to pass a marked rope was used to calculate speed. Modern technology now provides electronic logs, which are highly accurate and much easier to use. Charted depths. When reading a chart, depths are indicated in 2 ways. Spot depths. These are specific numbers, like 27, which indicate the depth below the chart datum. Contour lines. These are lines connecting points of equal depth. The spacing of contour lines provides insight into the seabed's features. If the lines are far apart, it means the seabed is smooth or gently sloping. Closely spaced lines indicate steep or rough terrain. A particularly important feature is the drying line, also called the 0-meter contour. This marks areas that are exposed at low tide. Any heights above the drying line are shown as drying heights, which are underlined, like 0.4, meaning 0.4 meters above chart datum. Depth and height. Understanding how depths and heights are referenced is essential for navigation. They are measured relative to different levels, including chart datum. This is the baseline, representing the lowest possible tide level. All depths on charts are referenced to this. Mean high water springs, MHWS. This is the average height of high tide during spring tides. Highest astronomical tide, HAT. This is the maximum tide level that can occur under normal conditions to the seabed. Today, echo sounders are the standard tool. They work by sending high-frequency sound waves to the seabed and measuring the time it takes for the echo to return. This time is then converted into a depth reading. Digital echo sounders make this process easier by displaying numerical depths. However, they must be used correctly. Factors like air bubbles, fish, or even the boat's propeller can interfere with the readings, so understanding their limitations is important. Most modern echo sounders allow you to set the display to show depth either from the transducer or from the keel. The latter is more useful for navigation, as it helps you avoid running aground. Additionally, many echo sounders include alarms for shallow or deep water. These are especially helpful when operating in unfamiliar or hazardous areas. Dead reckoning, DR. Dead reckoning is a method of estimating your position by using the distance and direction traveled since your last known location. To perform, DR. Use your compass to find the direction you're traveling. Measure the distance you've traveled using your log. Mark your estimated position on the chart with dividers and the latitude scale as a distance reference. Don't forget to account for variations and deviations when converting true bearings to compass bearings. This ensures your plotted course is accurate. Errors and calibration. No navigation tool is perfect, and errors can occur. For example, logs may overread or underread due to water flow, drag, or improper calibration. To correct these errors, you need to calibrate your log. Calibration involves comparing your log's speed readings against a known distance or GPS data. Run tests in Navigator's toolkit. Every navigator should carry a basic set of tools for chart work. These include a plotter, such as a Breton-type plotter or parallel rulers, dividers to measure distances on charts, pencils, erasers, and a pencil sharpener. Optional, but helpful tools include a hand-bearing compass to measure angles directly from landmarks, binoculars for spotting navigational aids, a handheld GPS as a backup to electronic navigation systems. Summary. Let's review the key points covered. Distance, measured in nautical miles, with 1 nautical mile equal to 1,852 meters. Speed, measured in knots, where 1 knot equals 1 nautical mile per hour. Depths and heights, referenced to levels like chart datum, MHWS and HAT. Charted depths, shown as spot depths or contour lines, with the drying line marking areas exposed at low tide. Echo sounders, measure depth using sound waves but require proper calibration and understanding of limitations. Dead reckoning, uses distance and direction travelled to estimate position. Toolkit, essential tools like plotters, dividers, and compasses are crucial for accurate navigation.
If you liked this video, make sure to click subscribe and check out the other videos in the series for a complete understanding of navigating the seas.